Hello my dear students, a very good evening to all of you. So warm welcome to Yupp Master School Foundation program. Hello Vijayalakshmi, hello Greta Reddy, hi Sudha, hi Jansi, hi Shashank, hi Ujjwal, hi Jatin. So hope all of you are doing well. So I remember these names because they are following the classes every day. So hope most of the students are following the classes every day. But every day I am observing these students in my class. So that's why I named them. Okay. So previously I told you, again I am telling you. So all these chapters which we are discussing in the classroom are most important for getting the best rank in IIT JEE. So that's why I am requesting you all my dear children. So please follow the classes very carefully, seriously and regularly. So every day we have only 2 classes in 2 different subjects. So from 5 to 6:30 you have to spend your valuable time. So this time is most precious. So if you are doing the work these 4 years, then after 4 years you will get the best IIT rank. So that's why I am requesting you all my dear students, so please follow the classes regularly. So now let us start the class. In number system, in previous classes we discussed the divisibility rules of different numbers and we did some mains model problems. Now in today's class we are going to do some more mains model problems related to divisibility. Now, so dear students, let us start the class today. So already we did some problems in the previous class. Now look at this problem. The number 8764x5 is divisible by 9. Then the least possible value of x where x is a 2-digit number. Options are given as A15, B14, C13 and D16. So this is the given problem. For this given problem we have to choose the correct option from the given 4 options. We have to choose the correct option from the given 4 options. Here the options are given as A15, B14, C13 and D16. But here the problem is, if the number 8764x5 is divisible by 9, then the least possible value of x is, where x is given as a 2-digit number. To solve this problem, we must know the divisibility rule of 9. If we don't know the divisibility rule of 9, then we are not able to solve this problem. So that's why we must know the divisibility rule of 9. So what is the divisibility rule of 9, dear students? Here, to check whether a number is divisible by 9 or not, add all the digits of the given number. Here the given number is 8764x5, 1, 2, 3, 4, 5, 6. Here the given number contains 6 digits. But among these 6 digits, one unknown value x is there. We have to find that value only with respect to the given problem. If the problem is 8764x5 is divisible by 9. If this number is divisible by 9, what is the value of x? The value of x may be any one of these 4 options, 15, 14, 13, 16. Here the divisibility rule of 9 is, if the sum of all digits of the given number is divisible by 9, then we can say the given number is also divisible by 9. For 3 and 9 we have the same rule. If the sum of all digits of the given number is divisible by 3, then we know the number is also divisible by 3. If the sum of all digits of the given number is not divisible by 3, then we can say the given number is also not divisible by 3. Similarly, we can apply the same rule for 9 also. If the sum of all digits of the given number is divisible by 9, then we can say the given number is also divisible by 9. If the sum of all digits of the given number is not divisible by 9, then we can say the number is also not divisible by 9. By applying that rule to each of the given 4 options. So, by taking option A, here by applying the rule. So, 8 plus 7 15 plus 6 15 plus 4 19 plus x plus 5. So, here by adding all the digits 8 plus 7 plus 6 plus 4 plus x plus 5. 8 plus 7 15, 15 plus 6 21, 21 plus 4 25, 25 plus 5 36. Here the number is 8764x5. 8764x5, that is divisible by 9. So, by adding all the digits 8764x5, by adding all the digits of this number 8 plus 7 plus 6 plus 4 plus x plus 5, 8 plus 7 15, 15 plus 6 21, 21 plus 4 25 plus 5 30, 30 plus x. 30 plus x. Now, in place of x we have to take 15, 14, 13, 16. But according to the problem, the number must be divisible by 9. In place of x, by writing 15, by considering option A, in option A we have 15. In option A we have 15. So, that is why in place of x, by writing 15, 30 plus 15, that is 45. 30 plus 15, that is 45, where 4 plus 5, by adding the 2 digits of 45, we got 4 plus 5 is 9. So, clearly 9 is divisible by 9. So, that is why we can take option A is the correct option. So, let us check whether the given options are also correct or not. So, since these are the single correct option questions, since option A is correct in the examination, we do not want to check whether the remaining options are correct or not. So, let us check whether the remaining options are correct or not. In place of x, if we take 14, so 30 plus 14, that is 44. By adding these 2 digits we got 8, but here 8 is not divisible by 9. So, that is why option B is not correct. In place of x, from the option C, by writing 13, 30 plus 13 43, 4 plus 3 is 7, but it is clear that 7 is not divisible by 9. So, that is why option C is also not correct. In place of x, from the option D, by writing 16, 30 plus 16, that is 46, 4 plus 6 is 10, again 1 plus 0 is 1. But this is clear that 1 is not divisible by 9. So, that is why option D is also not correct. So, already we got option A is the correct option for the given problem. So, in the examination, if we get the first option as the correct option, you do not want to check whether the remaining options are correct or not, because these are the mains model problems. In advanced model questions, we have the questions like this: one or more than one correct option type, one or more than one option correct type. So, for those problems we have to check the remaining options also. So, when a question has one and only one correct option, if we get the first option as the correct option, then we need not to check the remaining options are correct or not. So, for this problem already we got 15 is the correct option. So, if the number 8764x5 is divisible by 9, then the least possible value of x where x is a 2-digit number. So, by recapping the divisibility rule of 9, we know if all the digits of the given number is divisible by 9, if all the digits of the given number is divisible by 9, then we can say the number is also divisible by 9. So, by adding all the digits 8 plus 7 plus 6 plus 4 plus x plus 5, we got 30 plus x. In place of x, by writing 15, 30 plus 15 45. So, we know 45 is divisible by 9. So, 4 plus 5 is 9. So, that is why option A is the correct option for the given problem. So, look at this problem. Among the following, the number divisible by 3. The options are given as option A 561110, option B is given as 221201, Option C is given as 2 2 0 0 0 2 2. Option D is given as 5 5 5 5 5 5. So 4 options are given. We have to choose the correct option with respect to the given problem. Here the problem is given as, here we have to choose the correct option. Among the following, the number divisible by 3. The number divisible by 3. Here we have to recap the divisibility rule of 3. So divisibility rule of 3 is just like the divisibility rule of 9. For the numbers 3 and 9, the divisibility rules are same. Sum of all digits of the given number is divisible by either 3 or 9. The given number is also divisible by 3 or 9. If you take 3, divisible by 3. If you take 9, divisible by 9. But it is not necessary that every number divisible by 3 is also divisible by 9. But it is very clear that every number divisible by 9 is also divisible by 3. So here we have the numbers. So A, B, C, D. So A contains 1, 2, 3, 4, 5, 6. So in option A we have 6 digits. According to the problem we have to choose the correct option. Here the problem is given as, among the following the number divisible by 3. So in every option we have to add all the digits. In every option we have to add all the digits of the number. If we get that number is divisible by 3, then we can take that is the correct option. So if you take option A, so 5 plus 6 plus 1 plus 1 plus 1 plus 0. So total 6 digits are there. By adding all those 6 digits, 5 plus 6 11, 11 plus 1 12, 12 plus 1 13, 13 plus 1 is 14. It is clear that 14 is not divisible by 3, or by adding these two digits 1 plus 4 is 5, but 5 is not divisible by 3, so that's why we can eliminate option A. Option A is not the correct option for the given problem. So if you take option B, 2 plus 2 plus 1 plus 2 plus 2 plus 0 plus 1. So 1, 2, 3, 4, 5, 6, 7. 7 digits are there in option B. By adding all these 7 digits, 2 plus 2 4, 4 plus 1 5, 5 plus 2 7, 7 plus 2 9, 9 plus 1 10. Again by adding these two digits we got 1 plus 0 1. But it is clear that 1 is not divisible by 3. So that's why we can eliminate option B. We can eliminate option B. So next, by taking option C, here the digits are 2 2 0 0 0 2 2. So this contains 1 2 3 4 5 6 7. 7 digits are there in option C. By adding all these digits 2 plus 2 plus 0 plus 0 plus 0 plus 2 plus 2. By adding 2 plus 2 4 plus 0 plus 0 plus 0 plus 2 6, 6 plus 2 8. So but we know 8 is not divisible by 3. So that's why the number 2 2 0 0 0 2 2 is also not divisible by 3. 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. So that's why option C is also not correct. Since the options A, B, C are not correct, then option D must be correct option. Option D must be correct for the given problem. So while writing the examination, if the first 3 options are not correct, then we can take option D as the correct option for the given problem. Here let us check whether option D is correct or not. In option D we have the digits 5, 5, 5, 5, 5, 5. So 6 digits are there. So 1, 2, 3, 4, 5, 6. 6 digits are there in the option D. So by adding 5 plus 5 10, 10 plus 5 15, 15 plus 5 20, plus 5 25, plus 5 30. Again by adding the 2 digits in 30, we got 3 plus 0 equal to 3. So clearly 3 is divisible by 3. So that's why the number 555555 is also divisible by 3. Okay. So here we have checked whether the number 555555 is divisible by 3 or not. But in the examination, don't check whether this number is divisible by 3 or not, because the first 3 options are not correct. the numbers lie in the first 3 options are not divided by 3. So that's why the number lies in option D must be divisible by 3. So that's why while writing the examination, don't check whether D is correct option or not. So since the first 3 options A, B, C are not correct, then we can take option D is the correct option for the given problem. So if the sum of all digits of the given number is divisible by 3, then we can say the given number is also divisible by 3. So next problem, the greatest number among the following which divide 3, 3, 3, 3 so on 300 times is. So option A is given as 3, option B is 9, option C is 27, option D is 81. Here we have to take 3, 3, 3, 3 so on 300 times. 3, 3, 3 so on 300 times. 300. So this is not 3 into 3 into 3 into so on 3. So 3, 3, 3, 3 so on 3 means this number contains 300 digits. This number contains 300 digits. The meaning of this is not 3 into 3 into 3 into so on 3. So don't think like that. The meaning of this is a 300 digit number. This is a 300 digit number. So we know when the sum of all digits of the given number is divisible by 3 or 9, that number is divisible by 3 or 9. So here by applying that rule, here 3, 3, 3. So for example, if we have 33, means we have 2 3's, 3 plus 3 equal to 6. So 6 is divisible by 3. So we can say 33 is also divisible by 3. If we have 333, means 3 3's are there, 3 plus 3 plus 3, that is 9. We know 9 is divisible by 3. So that's why 333 will also divisible by 3. So here 2 3's are there, 2 3's are 6. Here 3 3's are there, 3 3's are 9. If you take 3 3 3 3 4 times, 3 plus 3 plus 3 plus 3, that is 12. So we know 12 is divisible by 3. So that's why the number 3333 is also divisible by 3. So 2 3's are there, 2 3's are 6. If 3 3's are there, 3 3's are 9. If 4 3's are there, 4 3's are 12. So like that, here we have 300 3's. Here we have 300 3's. So 300 3's, 2 3's are there, 2 3's are 6. If 3 3's are there, 3 3's are 9. If 5 3's are there, 5 3's are 15. If 10 3's are there, 10 3's are 30. Just like that. So since 300 3's are there, then we can write 300 into 3 is 900. So 3 plus 3 plus 3 plus so on plus 3, 300 times. By adding all those 300 digits, we got 900. So clearly we can say this 900 is divisible by 3, 300 times. Similarly, this 900 is divisible by 9 also, 100 times. If we take 27, 900 by 27, 9 3's are 27, 900 times, but 100 is not divisible by 3. So we can eliminate option C. If we take option D, that is 81. So 900 by 81, 9 times, 100 times, 100 by 9, but 100 is not divisible by 9. So that's why we can eliminate option D also. So here 3 and 9 are correct. So where 900 is divisible by both 3 and 9. But two options are, but between these two options we have to take only one correct option. So from A and B, we have to take only one correct option. So which option we have to take? Either option A or option B. So but here we can take the option B only, because according to the problem, the greatest number, according to the problem, the greatest number among the following which divide 3 3 3 3 so on 300 times is. So here 3 is correct, 9 is also correct, but by observing 3 and 9, the greatest number is 9 only. So that's why we can take option B is the correct option for the given problem. So we can take option B is the correct option for the given problem. Okay, here 3, 3, 3, 3, so on 300 times, that is divisible by both 3 and 9, that is divisible by both 3 and 9. But by observing the number 3 and 9, so clearly we can say 9 is the greatest. 9 is the greatest number. So that's why with respect to the problem also we have to take the greatest number. The greatest number among the following which divide 3, 3, 3, so on 300 times, that is 9 only. So by observing 3 and 9 we can say 9 is the greatest number. So that's why the correct option for the given problem is option B only. So that is 9. Next. So look at this problem. Among the following the number divisible by 6. So actually we can discuss about 6 later. So actually here 6 is the not a prime number. So by writing 6 as 2 into 3. So the number divisible by 6 means, here 6 can be written as 2 into 3. 6 can be written as 2 into 3. So by writing 6 as 2 into 3, if a number is divisible by both 2 and 3, we can say the number is divisible by 6. For example, if you take 12, here clearly 12 is divisible by 6. The same number 12 is divisible by 2, 6 times, and 12 by 3 4 times. So that's why if a number is divisible by both 2 and 3, then that number must be divisible by 6. So among the following the number divisible by 6. The number divisible by 6 means that must be divisible by 2 and 3. That number must be divisible by 2 and 3. So 6 4 ja 24, that is divisible by both 2 and 3. 2 12 ja 24, 3 8 ja 24. Okay, 3 8 ja 24. So if you take 42 is divided by both 2 and 3. So here if you take 3 ja 9. 9 is not divisible by 6 and also not divisible by 2. A number is divisible by 6 is nothing but that number must be divisible by both 2 and 3. So when a number is divisible by both 2 and 3, then we can say that number is also divisible by 6. If you take 14 is divisible by 2 7 times, but 14 is not divisible by 3. So that's why the number not divisible by 6. Okay. So if you take 3 7 ja 21. If you take 21 is not divisible by 2, but we can say 21 is divisible by 3. 3 7 ja 21. So here 21 is divided by only 3 but not by 2. So that's why the number 21 is not divisible by 6. A number which is divided by both 2 and 3 is divisible by 6. So that is the divisibility rule of 6. If a number is divisible by both 2 and 3, where 2 is a prime number and 3 is also a prime number, in future classes we can discuss about the prime numbers. So to check whether a number is divisible by 6 or not, we have to check that number is divisible by both 2 and 3. So here we have to recap the divisibility rules of 2 and 3. So what is the divisibility rule of 2? Here the options are given as 5 6 7 8 3, 5 4 6 7 2. So option C 1 1 1 1 1 2, option D 4 5 6 7 5. Okay. So what is the divisibility rule of 2? So if the last digit of the given number is either 0 or an even number, If the last digit of the given number is either 0 or an even number, then the number must be divisible by 2. So by observing option A, the last digit is 3. So we can eliminate option A. So that may be divisible by 3. But here the last digit is 3. So clearly this number 56783 is not divisible by 2. Similarly, 54672, this may be divisible by 6. 111112, the last digit is 2. This may be divisible by both 2 and 3. By observing option D, the last digit is 45675, where the last digit is 5. So that's why clearly the number is not divisible by 2. So that's why options A and D are not correct. Options A and D are not the correct options for the given problem. So the correct option may be either B or C. Either B or C. So option B and option C. Clearly the last digit is 2. The last digit is 2. Clearly we can say the number 54672 is divisible by 2. In option C we have 111112. This number is also divisible by 2. Okay. Next, check with 3. Check whether the number lies in option B and option C is divisible by 3 or not. So what is the divisibility rule of 3? If the sum of all digits of the given number is divisible by 3, then we can say the number is also divisible by 3. Here by adding all the digits of the given number in option B. So 5 plus 4 9, 9 plus 6 15, 15 plus 7 22 plus 2, here we are getting 24. We are getting 24. By adding all the digits of the given number 5 plus 4 9, 9 plus 6 15, 15 plus 7 22 plus 2 24. Again by adding these two digits 6. Clearly we can say 6 is divisible by 3. 6 is divisible by 3. So the number lies in option B is divisible by both 2 and 3. So that's why we can take option B is the correct option for the given problem. We don't want to check whether option C is correct or not. Here let us verify whether that is correct or not. But in the examination, since option B is correct, already options A and D are eliminated. So by checking option B is the correct option, we don't want to check whether option C is correct or not. So because these are the single correct option questions. So by adding all the digits in the option C, by adding all the digits of the number, so which lie in option C, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, 5 plus 2 7. But it is clear that 7 is not divisible by 3. So that's why option C is not correct. So among these 4 options, the number divisible by 6 is option B only. Here the divisible rule of 6. So write 6 as the product of two numbers, 2 into 3. We can write 6 as 2 into 3. If any number divisible by both 2 and 3, if any number divisible by both 2 and 3, then that number must be divisible by 6. So that's why for every option we have to apply the divisibility rules of 2 and 3. So what is the divisibility rule of 2? If the last digit of the given number is either 0 or an even number. If the last digit of the given number is either 0 or an even number, then we can say the number is divisible by 2. So the divisibility rule of 3 is, if the sum of all digits of the given number is divisible by 3, then we can say the number is also divisible by 3. By applying the divisibility rules of both 2 and 3, we are getting option B is the correct option. So by observing options A and D, we can say they are not divided by 2, because in both A and D the last digit 3 and 5, they are not even numbers. So that's why we can eliminate options A and D. By observing the remaining options B and D, by adding the digits, by adding all the digits of the given number, here we got 24, that is 6, here we got 7. By observing 6 and 7, 6 only divisible by 3. So that's why we can take option B is the correct option. So to check whether a number is divisible by 6 or not, we have to check whether that number is divisible by both 2 and 3. So next, among the following the number divisible by 7 is. Among the following the number divisible by 7 is. Here the 4 options are given as option A 343, option B 3 power 7, option C 3 power 77, option D 5 power 777. So by observing these 4 options, we have to choose the correct option with respect to the given problem. Here the given problem is among the following the number divisible by 7. Among the following the number divisible by 7. So to solve this problem, we have to recap the divisibility rule of 7. So what is the divisibility rule of 7, my dear students? Here the divisibility rule of 7 is to check whether a number is divisible by 7 or not. To check whether a number is divisible by 7 or not, double the number in units place. Double the number in units place and subtract it from the remaining digits. From the remaining digits of the given number. Then you will get a new number. If that number is divisible by 7, then we can say the number is also divisible by 7. So the divisibility rule of 7 is, so double the number in units place of the given number. Double the number in units place of the given number and subtract that from the remaining digits. If that number is divisible by 7, then we can say the given number is also divisible by 7. So by taking option A, in option A we have the number 343. So according to the rule, double the number in units place, where the number in units place is 3. Where the number in units place is 3. Double the number 3 means that is 6. So subtract 6 from the remaining digits. So 34 minus 6, that is 28. So it is clear that 28 is divisible by 7. So let us apply the rule. Where the number in units place is 8. Double the number 8 means 16. Subtract 16 from 2. So that is 2 minus 16, that is minus 14. So minus 2 times. So that's why option A is the correct option for the given problem. Option A is the correct option for the given problem. So to check whether a number is divisible by 7 or not, double the number in units place. The number in units place is nothing but the last digit of the given number. Last digit of the given number. So double the last digit of the given number and subtract it from the remaining digits. If that number is divisible by 7, then we can say the given number is also divisible by 7. By applying that rule to the option A, here we have 343, where the number lies in units place is 3. Double the number 3 means that is 6. So 34 minus 6, that is 28. So again by double the number 8, that is 16. 2 minus 16 is minus 14. We know minus 14 is divisible by 7. So that's why the correct option for the given problem is A. So if you don't want to check whether the remaining options B, C, D are correct or not, because for every problem there exists only one correct option. So already we got the correct option 343. So that's why option A is the correct option for the given problem, where 3 power 7 means 3 into 3 into 3 into so on 7 times. 3 power 77, 3 into 3 into 3 into so on 77 times. 5 power 77, 5 into 5 into 5 into so on 777 times. So 5 square, 5 into 5, 5 cube, 5 into 5 into 5, like that. 5 power 777, 5 into 5 into 5 into so on 777 times. So already we got the correct option for the given problem, that is 343. So that's why the number divisible by 3 among the given 4 options is 343. So that's why option A can be taken as the correct option for the given problem. Next, among the following the number divisible by 5. Here also we have 4 options. A 5555 power 4, Option B 7 power 5555. 7 power 5555. Option C is given as 4 power 555. Option D is given as none of these. So before solving this problem, we have to recap the divisibility rule of 5. We have to recap the divisibility rule of 5. When the number is divisible by 5. So we know the divisibility rule of 5. To check whether a number is divisible by 5 or not, the last number of the last digit of the given number must be either 0 or 5. Then only the number should be divisible by 5. If we have the last digit other than 0 and 5, then we can say the number is not divisible by 5. So the divisibility rule of 5 is, if the last digit of the given number is either 0 or 5, if the last digit of the given number is either 0 or 5, then we can say the number is divisible by 5. Otherwise the number is not divisible by 5. If we take option A, in option A we have the number 5555 power 4. The meaning of this is, we have to write 5555 power 4 like this. 5555 into 5555 into 5555 into 5555. So product of 4 times. Product of 4 times where 5555 is there. For example, 5 power 4 is there. 5 into 5 into 5 into 5, 4 times. Here we can add 5555 power 4. Here also we can add 4 times. 5555 into 5555 into 5555 into 5555. Here by multiplying these 4 numbers, here the last digit is 5 and 5. 5 into 5, 25. Again the last digit is 25. If you multiply that 5 with this 5, again you will get, so 5 5s are 25. Again the last digit is 5. If you multiply that with this 5, again 5 5s are 25. So whatever the digits may be, so before 5 may be, so the digits may have 10 digits or 20 digits or 100 digits. Whatever the number of digits before 5 may be, here we have to check whether the last digit is either 0 or 5. By observing clearly, the last digit is 5. So the number 5555 power 4 should be divisible by 5. The number 5555 power 4 should be divisible by 5. Here by writing 5555 power 4 as the product of 4 times, 5555 into 5555 into 5555 into 5555. So by multiplying these, we don't want to expand the total. So just we have to check whether the last number is either 0 or 5. We don't want to find all the digits before 5. Here we have to check whether the last digit is either 0 or 5. So by multiplying these 4 numbers, we must get the last digit as 5 only. So that's why the number 5555 power 4 is divisible by 5. So that's why option A is correct. Similarly, if you take 7 power 5555, 7 into 7 into 7 into so on, 7, 5555 times, but by multiplying all those 7s, we are not getting either 0 or 5. So that's why option B is not correct. Similarly, by writing 4 power 555 as 4 into 4 into 4 into so on 4, 555 times, here also we are not getting either 0 or 5 as last digit of the number. So that's why option C is also not correct. Option D is given as none of these. So to check whether a number is divisible by 5 or not, so we have to observe the last digit of the given number. If the last digit of the given number is either 0 or 5, if the last digit of the given number is either 0 or 5, then we can say the number is divisible by 5 by writing 5555 power 4 like this, by multiplying all these 4 numbers. So, we do not want to expand that, just we have to check whether the last digit is either 0 or 5, 5 5 is 25, again 5 5 is 25, again 5 5 is 25. So, that is why we have the number like this, so on 5. So, we do not want to check what the digits before the 5 are. So, just we have to check whether the last digit of the number is 5 or not. So, clearly the last digit of the number is 5. By multiplying these 4 numbers, the last digit is 5. So, that is why the number 5555 power 4 is divisible by 5. So, that is why for the given problem, the correct option is A. Next, look at this problem, children. Among the following, the number divisible by 8. Here we have 4 options. The options are given as option A 96354142. Option B is given as 36450176. Option C is given as 57064214. Option D is given as 87462. Before solving this problem, we have to recap the divisibility rule of 8. We have to recap the divisibility rule of 8. So, how can we say the number is divisible by 8 or not? So, what is the divisibility rule of 8? In the given digit, if the last three digits of the given number is divisible by 8, then we can say the number is also divisible by 8. So, that is why in every option we have to take the last 3 digits of the given number. In every option we have to take the last 3 digits of the given number. By taking the last 3 digits of the given number, and we have to check whether that number is divisible by 8 or not. If the last 3 digits of the given number is divisible by 8, then we can say the number is also divisible by 8. So, by observing option A, the last 3 digits are 142. Let us check whether 142 is divisible by 8 or not. 8 1 ja 8, 8 2 ja 16. So, 14 minus 8, 6, 62. 8 7 ja 56, 8 8 ja 64, 6. So, 6 is the remainder. So, that is why the number 142 is not divisible by 8. So, that is why we can eliminate option A. When 142 is not divisible by 8, then we can say the number 96354142 is also not divisible by 8. Next, let us check whether option B is correct or not, where the number in last 3 digits is 176. Let us check whether 176 is divisible by 8 or not. Let us check whether 176 is divisible by 8 or not, where 8 2 ja 16, 17 minus 16 1, 6, again 8 2 ja 16, the remainder is 0. So, clearly the number 176 is divisible by 8. So, that is why the number 37450176 is also divisible by 8. So, that is why for the given problem we can take option B is the correct option. We can take option B is the correct option. So, similarly, if we check the option C and D, in option C the last 3 digits, the number in last 3 digits is 214. By verifying, by checking whether 214 is divisible by 8 or not, 8 2 ja 16, 21 minus 16 5, 54, 8 6 ja 48, 14 minus 8 6. So, clearly 214 is not divisible by 8. So, the number 57064214 is also not divisible by 8. So, option C is eliminated. If you take option D, where the number in last 3 places is 462, the number in the last 3 places is 462. Let us check whether 462 is divisible by 8 or not. So, where 8 5 ja 40, 46 minus 46, 62. So, 8 7 ja 56. So, 6 is the remainder. So, So 6 is the remainder. So 8 5 is 40, 46 minus 46, 62, 8 7 is 56. Here clearly the number 462 is not divisible by 8. So we can say the number 87462 will also not divisible by 8. So that's why we can eliminate option D. So for the given problem, the correct option is only B. So by considering the last 3 digits of the number in every option, by considering the last 3 digits of the given number in every option A, B, C, D, only 176 is divisible by 8. So that's why we can say the number 37450176 is divisible by 8. Here the number 142 is not divisible by 8. The number 214 is not divisible by 8. The number 462 is not divisible by 8. But the number 176 is divisible by 8. So 37450176 is also divisible by 8. So to check whether a number is divisible by 8 or not, consider the last 3 digits of the given number. If the last 3 digits of the given number is divisible by 8, then we can say the number is also divisible by 8. So according to that rule, the correct option for the given problem is B only. Next, look at this problem. Among the following, the number divisible by 9. Here the options are given as option A 3444, option B is given as 4 power 999, option C is given as 5 power 9, option D is given as all of these. The general divisibility rule of 9 is, if the sum of all digits of the given number is divisible by 9, then we can say the number is divisible by 9. But here it is not possible to apply that rule, because here 3 power 444, 3 power 444 means here we have to write 3 into 3 into 3 into so on 3 444 times. So this is not a 444 digit number. 3 power 444 means 3 into 3 into 3 into so on 3 444 times. Here by multiplying all these 3's, 444 3's are there. 3 into 3 9, 9 into 3 27, 27 into 3 81, 81 into 3 243 so on. The last 3 is 444 to 3. If you multiply all those 3, you will get some number. That may be 10 digit number or 15 digit number or 20 digit number. By adding all the digits of that number, if that number is divisible by 3, then we can say this is also divisible by 3. But it is not easy to check like that. Here 3 into 3 into 3 into so on 3 444 times, where 3 into 3 can be written as 9. 3 into 3 can be written as 9. So 9 into 3 into 3 into so on 444 times. Clearly this number is divisible by 9. So to check whether a number is divisible by 9 or not, we have to add all the digits of the given number. But in option A, so by writing 3 into 3 into 3 into so on 3 444 times, it is not possible to check like that. So that's why here I am writing 3 power 444 as 3 into 3 into 3 into so on 3. 3 into 3 is 9. For example, 36 is there. 36 is there. So clearly we can say 36 is divisible by 9, 9 4 times. If you write 36 as 9 into 4, so by 9, 9 and get cancelled, that's why 36 is divisible by 9. So here also if you write 3 into 3 into 3 into so on 3 444 times, we can write 3 into 3 as 9. So this is 9 into some value, 9 into some value by 9, 9 9 cancel. So that's why option A is the correct option. So you don't want to check the remaining options B, C, D are correct, or option D is given as all of these. Option D is given as all of this. If you take option B, 4 power 999 means 4 into 4 into 4 into so on 4. Here we have tried that as 999 times. 999 times. 4 into 4 16. 16 4 is 24 like that. But it is clear the product of these 4 into 4 into 4 into so on 444 times not divisible by 9. So that's why option B is not correct. When option B is not correct, then we don't want to check whether option C is correct or not. Here 5 power 9, 5 into 5 into 5 into 5 into so on, 5, 9 times. So you will get 5 5 is 25, 25 into 5, 125, like that. That is also not divisible by 9. So when B and C are not correct, so we don't want to take option D. So option D is all of the above. So for the given problem, the correct option is 3 power 444, that is option A. Among the following, the number divisible by 9, that is 3 power 444, right? 3 power 444 like this, 3 into 3 into 3 into so on 3, 444 times, where 3 into 3 can be written as 9, 9 into so on by 9, 9 9 get cancelled. So that's why the correct option is A. So dear students, hope you understood the class today. Let us do some more mains model problems related to